By the way, you can also specify the limits for the logs and for many other things. Let's actually go back down. Let's actually grab a bigger boat. Let's actually go out. Okay, and I'm going to clone a repository called github.com type level cats.git, and this is a functional utility library for Scala, and it's it's not small, so it's going to take a couple of seconds to actually pull it down, even though I have a good connection. So what I essentially want to show you is that you can search for the logs, and you can specify the ranges. And I also want to show you the git blame command, which will basically take every line in a file and show you who touched it, who was the last person to actually touch it, at least like on your current commit. All right, so it almost finished. I don't have anything else to say until it's going to finish, so I'm just going to speed it up in post. All right, let's go into it. Okay, so there's an alias called GBL, which stands for git blame -b and -w. -b stands for boundary commits. Boundary, I was about to say binary. No, -b stands for boundary commits, and we're going to talk about them in just a second. And -w basically stands for white spaces, so it's gonna ignore white spaces. Okay, so now we can do GBL. Show me the lines, and you can specify the range of the lines. So somewhere between the lines 35 and 45 in a file called, again, fzf to the rescue, Control T, and I'm going to search for the file called monoid K. This is the file that I want. Okay, enter, enter, and there we go. Okay, I'm going to make the font a little bit smaller, like this. Okay, so now everything fits. Okay, so over here you see the commit hashes, and we see some empty stuff. This was the -b flag, and we're going to talk about it in just a couple of seconds. By the way, notice that this file was renamed at some point, so it was over here. Now it's then it was over there. You see who did it and when, and you also see the line. This feature is very useful when you're inside of an IDE, and we're going to see this a bit later. All right, so let's run the same command without the B. Okay, so we're going to do it manually. Git blame just -w, and we can actually remove it. Okay, so now over here we're seeing the commit messages with a caret, and this git blame command, same as the log commands and all of the others, it can accept temporal queries, right? So for example, you could say show me the blame, but only like what happened in the last, I don't know, 2 days or something like this, right? And then there is a chance that there's something in the line, the line was changed, before these 2 days, right? And then with the -b, it would show, it would just put an empty space over here. Without the B, it would show you the closest parent. Now, in this particular case, and I have no idea why Git does it, Git actually treats the very root commit, the very original one, as a boundary commit for some reason, and there is a way to turn it off. So you can go over here and also in the end specify root, and then it will actually find it. So it turns out that this monoid K was there from the very beginning. I believe this 9D18 was, let's actually check. Yeah, 9D18, right? So this is the initial commit. This is exactly why it happened. Okay, 9D18. This is the initial commit. I have no idea why Git does this. In fact, by the way, let's increase the font a little bit more. I believe it was something like this. Let's actually increase a little bit more so that it's more readable. I have no idea why Git does it. Okay, so you can also do GBL with it, right? So GBL root, and now it's fine. As you can see, this is the 9D over there. Now there's actually a reason why I brought in avzf, because I want to show you a couple of things. First of all, as a reminder, there are these couple of aliases, alias GB and alias GBR. Okay, so git checkout, git branch, and git branch remote. You can create awesome aliases with avzf. For example, this is going to be avzf git checkout. Okay, what it's going to do? Well, it's going to do the regular git checkout. Okay, and as an argument, it's going to need a branch. And where is it going to get the branch? Well, it's just going to search for the local branches. It's going to pipe them to avzf like this. Okay. So let me actually add the other ones before I actually run this. So this is going to be the same one, but for the remote branches. Okay, so we're going to say grab the remote branch and track it locally. Okay, GBR, again, it's this one over here. Again, pipe it to FZF. And also we're going to have exactly the same one for tags, COT. Okay, so it's going to be GCO. We're not going to have the tracks over here. We're going to have G tag. Okay, so if I do fgco, it's going to try, it's going to list all the branches that I have locally. And by the way, when you clone a repository, you're cloning only, you're getting down only one branch, which is master. So if I run this, it's going to display a list with only one branch. right? There you go. Not really, not really spectacular. FGCOR is much more fancy because this is a public repository and a bunch of people are contributing to it. And as you can see, a bunch of branches. So let's say we're searching for memoize. I'm going to do memo, enter, bam. I'm down there. It tracks this branch. A similar thing for the tags. FG, check out the tag. We're seeing all the tags. Let's do 1 dot 2 dot whatever 0. Bam. We're somewhere in the middle of nowhere. We're in a detached hat. All right, let's go back to master GCM. Now, in the very first videos, we actually mentioned tags very briefly, but actually decided to talk about them a bit more extensively. So this is what we're going to do now. So let's actually go back to Scala seed. Right, so this is my repository. It wasn't, it's on the dev inside you GitHub profile. So what we're going to do now is we're going to steal it because I want to create a couple of tags, and I also want to push the tags, and I don't want to push them to my repository. Okay, we could have actually added another remote, but I don't want to confuse you. So we're simply going to remove the .git directory. So now it's basically stolen because now we're just going to say, haha, it's ours now. Okay, and we're going to commit everything that is in there. I'm going to say initial commit. All right, great. So now we're going to go and we're going to actually create it. So we're going to open our organization. We're going to create a new repository, and we're going to call it, I'm going to call it the same just so that it's less confusing, but technically we don't need to. Okay, scalaseed.g8, it's private. Okay, just let's create the repository. All right, make sure that it's SSH, just copy over here. Gonna go over here and we're gonna do GRA as a reminder. GRA, just git remote add, origin is this thing, and let's see it like this, and GPSUP, which will push the main branch over there. All right, so this way we can start talking about tags, and this branch is going to be pushed. So if I refresh it, there we go. It's right there. By the way, this thing should probably stay. All right, so let's talk about tags. Tags are pointers that don't move automatically. Git has two kinds of them, the annotated tags and the regular, or sometimes called lightweight tags. Now, there are two major differences between them. One is, a rather technical reason, and another one is their purpose. The technical reason is that the annotated tags are the only so to say real tags. They are real objects in Git's databases. They contain additional information like the author and the date and so on. Lightweight tags don't add anything. It's just a pointer that literally points to commit, as we will see in just a couple of seconds. The second difference is their purpose. As already mentioned, the annotated tags are the only proper tags. These are the real objects in Git's database. These are the tags that you want to have all the time, and these are the tags that you actually want to push. Even though it is possible to push lightweight tags as well, I cannot think of a reason why you would. In fact, Git has a couple of mechanisms to push the tags. You can push an individual tag simply by specifying its name. You can push all tags. You can push all annotated tags, but it is not possible to push only all lightweight tags, and I believe this is done for a reason. The lightweight tags are for you. All right, so let's create a couple of tags, and for this I'm going to do this thing, and inside of it I'm going to go over there. I'm going to go into dev scala seed, and I'm going to do this thing. Remember that prints out the log all the time for us. Okay, every time I change something, it refreshes over there. Okay, so the first thing that we're going to do is we're going to simply tag 1.4, right? So this is going to be the name of our tag. Tags are usually used to annotate releases, but again, you would usually use annotated tag for this. So this is a lightweight tag, right? So we just do this, and over there it's added. Okay, so you can also do tag, and you can say that this is going to be an annotated tag 1.5, and an annotated tag needs a message. Okay, so we're going to say, I don't know, message. All right, get out of there. Okay, so now we see two tags. You kind of don't see right now which one is the annotated one and which one is not. This is also how you delete the tags. Let's delete the annotated tag. And we're doing this so that I can show you that when you create a tag, if you're specifying the message, right? So if, for example, you do this and you're specifying the message, then your tag automatically becomes annotated even though you didn't specify the -a. Okay, so we're going to do this, and now we're going to see that if we're using cat file, which will show us the type of 1.4, it's going to say it's actually just a commit because it's a lightweight tag. It's not a real object in Git's database. Okay, but if we want to do the 1.5, it's going to show us, oh, no, this is the real deal, right? This is an actual tag. So for example, if we git show 1.4, we're going to see the commit, and if we git show 1.5, 1.5, then we're actually going to see more information. We're going to see this. We didn't see this before, right? So this is the tagger, this is the date, and this was also the message. Now you can obviously tag something that is in the past, and for this we're going to need to create a commit. So we're going to pipe whatever into a file. We're going to commit. We're also going to call it whatever. So we're going to do v1.3, and we're going to say please tag the one before. Okay, so so we're currently over here. 1.3 will be added over here like this. There we go, 1.3. So we're essentially added 1.3 to it exactly the same one. There are a couple of ways to list that, which is why we're going to disable the pager real quick. Pager tag false. Let's clear everything. Okay, so if you just do gtag, it will list them. Okay, if we do gtag hyphen list, same thing. Gtag hyphen l, same thing. But you can also search, and when you do search, you actually need to specify either hyphen l or hyphen list. Okay, so for example, if we search with the regex, I'm actually not sure if it's regex or the glob patterns, but I think it's regexes. Okay, so if you search for this, you find all of them. If you search for this, you don't find anything. Now this is how you push tags. You can push tags individually like this, 1.3. Right, there we go. Come on, push it. There we go. You can also do like this, follow tags, and this will transfer only the annotated tags, right? So as you can see, it's not going to push the 1.4. Yeah, so as you can see over here, it pushed to 1.5. 1.4 was the lightweight tag, so we didn't actually push it. Okay, and now you can also do the same thing with tags, and this one will actually push all of them. The only one that is left is 1.4, so there we go, it pushed 1.4. Okay, let's actually go over there and see them. So if I refresh, we're going to see that there are 3 tags. Click over here, here they are, 1.3. We'll click over here, initial commit, 1.4, initial commit, 1.5 will actually show the message of the tag. And obviously you can click on them and you're going to see the, the stuff, right? So this is, I already mentioned this in the very beginning. Usually, GitHub has a concept of releases over here, and they essentially start with tags, right? So you can select tag, draft a new release, blah blah blah. All right, let's go back over here. Let's go back over here. Now there's also an alias called GPOAT, which says git push origin all, and all means all branches. Usually we were doing like git push, it would push only the current branch. All pushes all the branches, and it pushes all the tags, as we have just seen over here. This is how you delete the tags, like this: 1.3, 1.4, and 1.5. There we go. All of them are gone, and this is how you delete them from the remote branch. Okay, delete 1.3, 1.4, 1.5. So it's just another push with a special delete flag. You give it a couple of tags, and there we go. They're deleted. If I refresh this, this three will disappear. Ta-da! Let's go back. One other cool thing is that remember when we were in the cats repository and we checked out a tag in the middle of nowhere, so we ended up with a detached head? Well, it turns out that there's a neat trick where you can check out a tag, right? So let's create a tag for this one, for the initial commit, okay, over here, my tag. So you can check it out and create a new branch at the same time, right? So again, GCB, git checkout, -b, new branch, name, and you give it the tag, right? So it goes over there and it also creates a branch over there. And that's pretty much all there is to know about tags. All right, now in the previous video, we learned how to interactively stage individual patches. What I haven't showed you is that this interactive staging, or this interactive choosing of the patches, can also be applicable for other commands as well. Okay, so let's go and unstage some changes real quick. So let's go over here, and I'm gonna go and I'm gonna make some changes. For example, let's say that I don't know, I'm gonna add a print line hello world over here, and I'm gonna go into some other file. Let's go to main, and I'm gonna say hi over here. Right, so if we go over here now, and if we run gd, then you see that we have the 2 changes. Okay, so if I'm gonna add all of them, right, like this, gd shows nothing, gds now shows everything because they're staged. Okay, so now as a reminder, alias grh is git reset, and we can do grh -- patch. In fact, let me actually go over here and close this one. Because I believe that as soon as we do this, we're going to need a bit more space. Okay, so we're doing a reset with patch. Okay, so the first thing that we're going to do is we're going to do the question mark, right? So as you can see, unstage this hung, don't unstage this hung, quit, unstage. You can read this thing pretty much yourself, right? So I don't know. Let's say yes, please unstage this one. Okay, and let's say no over here, right? So GD now shows this one, GDS now shows the other one. You can also do this interactive stuff with stashing, and I highly recommend you not to do this when you have something staged like we do right now. Like half of the things are staged, another half is not staged. In fact, I'm gonna do this on purpose, and I'm gonna try to stash something interactively. Okay, so I'm gonna do stash hyphen p. So it shows us this one, for example, which is fine because this one is not the one that is stashed. Let's say yes, but it also shows us this one, which is weird because this one is already staged. In fact, I think it would have been better if I said no to the previous one and yes to this one. In fact, I'm going to just say yes to this one. Okay, so now it says that it staged something, right? So I'm sorry, stashed something, right? But I said yes to both of them. So now it's stashed both of them, but we're still seeing that there's something else. So if we do GST, it's going to say, okay, we modified the file. Okay, well, show us. Well, we added, we removed this one. What? How? This is super weird. Let's actually see. So GSTL is stash list. Okay, so it's over there. All right. Well, G stash show. Okay. Well, there's changes to both of the files. Well, what happened to this one then? So essentially, when you interactively stash stuff, please make sure that your working directory is empty. And by the way, there's also GSTS, which is the same thing, but with text. And as you can see, so it's stashed like both of these, right? But somehow this guy got left over. In any case, whatever. Let's just reset everything. Now, one of the last things that is left to do to discuss today is the infamous git bisect command. But before we talk about it, let me be crystal clear about one thing. Git has many fancy tools that allow you to change the state of the repository quite drastically. For instance, if you want to bring in the latest changes from the main, not a big deal, just do a rebase. Or if something comes up, then you can really quickly stash your changes and check out a new branch. Not a big deal with Git, but there's a huge but to this. As a reminder, this is mostly a Scala channel, and Scala is a compiled language. And in compiled languages, you want to hold on to your compile caches as if your life depended on it. Now, even though Git makes it very simple to hop between commits, tags, branches, what have you, you really don't want to do this in a compiled language. In fact, me personally, when something comes up, I simply just copy paste the entire directory just so that I don't have to switch the branch, right? Because I really want to hold on to my incremental compilation caches. Git is cool and all, and I consider myself an advanced Git user, but sometimes you just have to use the right tool for the job. All right, so what is Git bisect? Git bisect is another search tool built into Git. It allows you to search for some semantics, some behavioral change in your repository. Usually you would look for a bug. You want to see which commit introduced this bug, but it doesn't need to be. You can be searching for anything. For example, in the example that we're going to go through right now, we're going to look for when a file was introduced to a repository. The way it works is that you say, okay, so we're currently on main, and currently things are bad. There is some bug. I have no idea when it was introduced. But what I also know is that 3 versions ago, things were good. And so you give these two things, and Git will search in this range for the commit that made things go bad. The way Git does this is it simply chooses a commit in the middle of this range, which is where bi comes from. Bi stands for two halves. And then it asks you, hey, take a look at this. Is it still good? And then based on your answer, it chooses the half to repeat the same search. Classic divide and conquer, or to be more precise, git bisect is the good old binary search. Now, this decision making can be done manually, but you can also automate it. You can write a script which should be either untracked or even better outside of the Git repository, because once Git starts hopping between the commits, your script is going to disappear, and you don't want that. All right, so essentially it's very simple. If your script returns a 0, then then Git knows that that this was still a good one, and then it goes into one half. And if it returns 1, then it's still a bad one. It goes into the other half. Very simple. Let's switch to the cats repository, which is slightly larger, and I already have a script prepared, right? So again, usually you would search for a bug, but in this particular case, we're going to search for a file called parallel, right? And if we're going to say 1, right, it means that this file exists which means that it's bad because we're looking for the state where this file did not exist, right? You kind of have to do this mental mapping between good and bad because originally Git bisect was designed for searching for bugs. In fact, if you read the manual page for Git bisect, you can actually rename a couple of things in there to ease this mental mapping. But if you use it once or twice, you actually kind of get used to it. It's very, very simple. Okay, so as a reminder, we need to give it two commits, right? So it's going to be like the current one. We're going to pretend like, okay, in the current one, this file obviously exists, but at some point it didn't exist, and I have no idea actually where. Like usually you would give it some I don't know, something like 3 versions ago or something. In this particular case, we're actually going to look for the very first commit, which is the initial commit, and it's actually very conveniently tagged for us. Okay, so we're going to say that over here things were still good, but currently on our head things are bad. Okay, so if we do alias gbss, we're going to say that this is the git bisect start. There are a couple of ways to start it, but the easiest way is to basically give it this information right away, right? So we just do gbss and we're saying, okay, right now things are bad, and over there things were still good. Okay, so now it started. So as you can see, it went to in the middle. Okay, so now what we need to do is we need to say gbs, which is actually, you know, the git bisect. Okay, so we're going to do gbs and we're going to say run, please run this search. Okay, so it's going to, you know, it already basically did one step. Now it's going to run the script, and in just a couple of seconds, bam, it found it. Okay, so it says bisect run success. So if we scroll up over here, it is going to say, so by the way, this is a very long commit message, right? So it just happened that this particular commit had a very, very, very long commit message. Okay, so look over here. Here, like this one. Okay, so this was basically the last step. It did the last hop. It says like after this there is nothing left, so this pretty much has to be it. And look at the commit message. It added this parallel type class, right? So it ran my script. The script says, it's there. This is where this file was not there. It says this is the first, you know, it calls it bad, but we weren't actually looking for a bug, right? But it actually found it, right? So look, I added it, and it happened on the 26th of October in 2017. Adds parallel type class. We see a tiny summary. By the way, I don't believe that I showed you the summary. Okay, hold on. If we do, by the way, this is the file over here, right? So if we do, by the way, so we still need to, so bisect is sort of like a rebase or a merge in the sense that it puts Git into this stateful state, right? So we need to exit the, exit the bisect. And by the way, you can also do gbs visualize, and if you had some tool, it would actually open this tool, open this commit in your tool, but actually it says like, hey, this is this commit. Okay, now it feels like as if we're currently on this commit, and we are, but we're also during the bisect, so we need to jump out of it. And the way you do is by doing gbsr, git bisect reset. Okay, but if you do this, we're going to go back to where we started, which was the main. If for some reason you actually want to stay here, you can do bisect bad, right? It's gonna go there. Okay, let's go back to master. Okay, so I don't believe that I showed you git log one line. You can also do s one line. I thought s would actually show the summary. Was it not s? Hold on. Yeah, it's this one. Yeah, it was the S. Hold on, GLOS. I'm sorry, GLOLS. What is this one? Stat. Right, this is what I did. Git log, one line, stat. Why didn't it work with -s? I thought -s would work. -s would work as well. Okay, it doesn't. Okay, so stat showed you these stats. How many changes were added and stuff. All right, and this was git bisect. This is pretty much everything you need to know, but you can actually read the main pages. There are a couple of flags, a couple of things you can twist and stuff. But this pretty much, what I showed you is pretty much the only thing that you actually really need. And as a reminder, right, so if this was a compiled project, and usually like in this script, you wouldn't search for a file. In this script, usually you would run your tests. Imagine it checks out the commit somewhere in the middle, has to recompile everything, it has to retest everything. In fact, recently a blog article came out about it. it, and I'm gonna post it in the description. There are cool things that you can do, like I don't know, you can cache compilations and stuff. It can get very very hairy, so it's not as simple as what I've just shown you. Even though like this is the the basic skeleton of a bisect. We're almost at the end of the video, so let me also show you a couple of things that are built into VS Code. Now, first of all, VS Code has a bunch of built things for Git, like even without plugins. I already have a plugin called Git Lance installed, so I'm not 100% sure about the things that I'm going to show you because maybe a couple of them are coming actually from Git Lance, and I'm just so used to them that I'm not even sure. The first thing that you see is the timeline of a file, and I put it over here. If you're just starting out with VS Code, it actually might be somewhere else. It might be like it might be over here. Why doesn't it show me? Like usually, I think I moved all of them over here. Like usually, yeah, like open editors and outline. Like usually they're like over here when you're starting out. So the timeline is also going to be over there. But I prefer to have it over here. In fact, let's actually close this one. Let's actually open this one. This one is much bigger, so it's going to show the timeline a bit nicer. Let's actually go to this parallel file, which is over here, right? And you can go and no, not now. You can see the timeline, and as you can see, like a bunch of things change. You can click. You see the diffs. You see a bunch of things. Okay. Also, you have the entire source code view over here. Right? So if you, I don't know, if you do some changes, they're gonna appear here. We've already seen stuff like this, right? What else? You have like contextual menus, right? So if you go, I don't know, over here, you can do like open changes with revision. Again, I'm not super sure if this comes from VS Code itself or from the Git Lance extension. One cool thing is over here, you can open file on remote, right? So we're just gonna click on it, and bam, it just finds it on GitHub and opens it. This is the file. Let's close it again. Also, Git has this thing built in over here, which automatically synchronizes the changes, right? So from time to time, it just fetches stuff. In fact, I disabled it. And in fact, in the previous couple of videos, I showed you a couple of aliases that I introduced myself, like, for example, GRBIOM, which is Git Rebase Interactive, was origin master. And I put in Git fetch in there. And I actually realized that it's not a good idea if I don't have control of what is currently fetched. So I actually removed it. So I'm actually going to go to my settings, and I'm actually going to show you Git auto fetch, right? So I disabled it. I don't recommend that you have it enabled, right? So this one, I'm sure it's built into VS Code. I thought initially that this was a plugin, but it's not. All right. Now let's talk about Git Lance. So Git Lance looks like this. It has this plugin over here. It brings in a ton of stuff. For example, these buttons, they come from Git Lance. Okay, so you can for example go and see the previous version and the previous version and the previous version and the previous version. As you can see, like there are many changes over there. Okay, like this. Okay, you can pretty much close this. Even if you do like some changes, if you do like print line hello world over here, you save the file, you see, okay, how did it look like before? Well, this is how it looked like before. Print line was not there. Okay, let's go and remove this. It adds a bunch of things to the to this view. Like all of these things, they come from Git Lance, branches, file history, repositories. You have thumbnails in there, really a bunch of things, right? I believe even like contextual things, like over here, like these things, like this thing, it might come from Git Lance. I'm really not sure. There are like a ton of things that are coming from this extension. It's, oh yeah, this one, yeah. How could I have forgotten? Like Git blame, right? So over here it says Travis Brown a year ago. Over here, like this line, Luca 3 years ago. You can also click on this one, and it will show you the blame, for example, right? It's going to show you the blame. You can turn it off. You can show the heat map, which lines were changing, most often, I guess. I'm actually not even sure. Toggle file changes. I'm not sure about this one, what exactly this one does, but as you can see, a ton of stuff built into this. Okay, another one that I'm going to show you is not super useful, kinda, but it looks pretty cool. So I'm actually going to show it to you. It's called Git Temporal, which is over here, this one. So I'm going to install it, and it's going to appear, I believe, somewhere here. Once it finishes installing, where is it? Over here. There we go. It's finished. Maybe I need to reload or something. There we go. I actually don't remember what I need to click to enable it. Maybe I need to do temporal. Yeah, open and get temporal. Okay, so it does this one. By the way, I have no idea if it's temporal or temporal. Okay, so it shows you the changes and it shows you like this timeline where like most changes happened. Okay, like it seems like in October a bunch of changes happened. You can actually click and you can see, and it's pretty fancy and whatever. Um, yeah, so you can zoom into the timeline. A bunch of it feels more like a toy. I don't know, like maybe like you can very fastly see like when the biggest changes came for some reason. But still, it's really really cool. And as I already mentioned, there are like millions of tools like this, and also there are millions of commands in Git. Even Linus himself doesn't really know them, and I haven't showed you. I haven't actually showed you all of them. It's pretty much impossible to cover all of them. And so, if there is something that you still want to know, something that I didn't cover, I highly recommend that you check out the Pro Git book, which is over here in Git's website. Over here it says Pro Git, and there is an online version and there is a PDF version, and they're both free, right? So it's over here. You can get the PDF, you can get the EPUB, you can click over here. So for example, if you forget how the rebases work, right? So you go to rebasing, click on rebasing, beautiful pictures. I actually read this book. I reread this book when I was preparing this series. Right, it's like 600 pages. There's like everything covered in there. Well, not everything, but because again, like pretty much like every day, like things are being added to Git. All right, we're pretty much done for today. In the next video, we're going to talk about Git hooks, and we're going to also talk about conventional commits, which technically goes a little bit beyond just Git, but it's very, very important. So I decided to add a video about it to this playlist. Okay, and for now, as always, it's been Vlad, devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider support me on GitHub sponsors or on Patreon, whatever you prefer, and let's watch my videos weeks and sometimes even months before everyone else, and most importantly, take care.